Thanks everyone for attending Cintoo's June 2022 webinar, where we have a customer testimonial where Julie Petit from CIMA Plus will discuss a 10-year tunnel project where she is using Cintoo as her solution for their laser scanning data. This webinar will be recorded for future use. Please type your questions in the Q&A panel and we'll answer at the end of the demonstration. For today's agenda, I will be doing a quick introduction to Cintoo Cloud for those who are not familiar with us. After that, we will have a customer testimonial from Julie Petit from CIMA Plus. She will give an overview of CIMA Plus and their services, an overview of the 10-year tunnel project, which she will discuss in detail, kind of the project overview, how she set up the project, and the collaboration and workflows that she imposes. After that, we'll have a brief Q&A. Following Julie's presentation, Dominique Poulican will come on and discuss some new features in Cintoo, including our new TurboMesh feature, as well as Cintoo Connect 2.1, which includes support for mobile devices. Following that, we'll have a brief Q&A and end the session. So now let's discuss Cintoo Cloud and how we are at the convergence of digital twins and reality capture. A digital twin is a realistic digital representation of assets, processes, or systems in the built or natural environment. We break this up into two distinct industries. The first one, being Industry 4.0, consists of automotive, oil and gas, manufacturing, power and utilities, chemical, or any industrial type of application or environment. The second one is what we call BIM, which really refers to the AEC industry, which includes architecture, construction, and engineering. This allows end users to prototype or run what-if scenarios and do simulations based on the reality capture data that has been captured. So you may have heard the term a digital twin challenge. What we're discussing here is the gap between what is really out in the field versus the virtual model that represents that location. This shows the true value of reality capture, as we can note the discrepancies between the real world and the virtual world. This brings us to digital twins and how scanning helps us collect as-built, truthful data. For BIM, it helps us to do asset management or do scan-to-BIM comparisons. Also very useful in the BIM coordination project or doing project reviews with the extended team or with the owners. For Industry 4.0, it can also be used for asset management, but also for doing retrofits or new layouts or modernization planning, as well as predictive maintenance or reverse engineering. So now let's talk about Cintoo's core technology. With Cintoo Connect, we take the 3D point cloud either as an E57, RCP, RCS, or FLS file and convert that locally on your computer to a 3D mesh. By doing this, we reduce the size of the footprint of the data anywhere from 10 to 20 times. This is what allows us to view this mesh in a browser very easily and quickly. Also, we have the ability to do a reverse transformation where we can bring the data, the mesh data from inside of Cintoo back down to the local computer as an RCP or an E57 file to be used in your authoring software. Through this process, there is no loss of information between the precision or the accuracy of the data collected. This is truly unique to Cintoo and is very valuable, as you can either download complete scans of an area or you can also crop a region and work specifically on an area, which also saves you time in the data footprint of the RCP or point cloud file that you're working with. I would now like to show you a brief video around our new TurboMesh Engine, which is a new feature that was recently added, and Dominique will give a further explanation later on in the presentation. Our industries are made of huge spaces full of complex geometries. Laser scanners capture those spaces as 3D points, but our world is made of surfaces. Point clouds are ambiguous and difficult to navigate. With Cintoo's TurboMesh Engine, what you see is how the world really is. With 3D meshes and surfaces, no interpretation errors, no measurement mistakes. Cintoo is now introducing its new TurboMesh Engine to navigate your scans and experience your as-built data as 3D surfaces, at the resolution of the source scanner with no compromise to accuracy. With TurboMesh, your 3D scans are now finally ready for metaverse experiences for everybody, experts and non-experts alike. Is point cloud viewing obsolete? So the Cintoo Cloud platform is all about being able to collaborate, share, and distribute your scan data with others on the project team. People can be based anywhere in the world, and you will be able to share your data real-time on the cloud in a SaaS application. All of your data is hosted in either Amazon Web Services or Microsoft Azure. You select which location for each project. Additionally, we are also SOC 2 Type 2 certified, which is one of the highest levels of certification that can be achieved and assures you that your project data is secure. So let's discuss how we get the data into Cintoo Cloud and collaborate, share, and distribute. First, you will collect your data out in the field using your scanner of choice, either a terrestrial or mobile. From there, you will register the data and use Cintoo Connect to push that point cloud data that has been transferred to a mesh locally on your machine up as a mesh inside of your Cintoo Cloud project. Everything inside of Cintoo Cloud is mesh-based. In the office, you can now go and create notes, reports, issues, take measurements, create annotations, as well as our shared viewer, which allows you to share with the extended team. You can also export that information from Cintoo Cloud as a mesh locally back down to your computer as a point cloud, either an RCP E57 or RCS, and use that in your authoring tool of choice. You also have the ability to create a crop of an area inside of Cintoo and export that information out as an OBJ, STL, or FBX unified mesh. We also have connections to other software solutions, such as Autodesk BIM 360, which allows you to bring in your models directly into Cintoo and compare your as-built data to your model data. And we can also push issues into BIM 360 or BIM Track and Procore as well. We are currently serving over 400 companies in 32 countries, which roughly consists of over 3 billion square feet of data, and up to 2 million scans have been uploaded, including 15,000 models and 25,000 users. Once again, we serve two main industries, what we call Industry 4.0, which is around oil and gas, manufacturing, energy, and also BIM and construction for your AEC customers around architecture, engineering, and construction. It is now my great pleasure to introduce you to Julie Petit from CIMA Plus, who will discuss how she is using Cintoo on a 10-year tunnel project. Thanks, Julie. You may now share your screen.
Thank you. Just sharing. Okay. So I'll present you a little bit of our company profile today and our group in reality capture, and then I'll move quickly to the project that I want to present, which is a underground tunnel project. It's an extensive rehabilitation project, and it's going to take 10 years to do. So it's a very interesting project to host on Cintoo. I'll explain why a little bit later. So I'm actually working at CIMA Plus for now 10 years, actually 7, well, it's 17 years. And I'm actually working with reality capture data for more than 15 years now. So we've been working with a lot of devices that I'll explain a little bit later in our group. So CIMA Plus is actually an engineering firm that provides services in many sectors, activities like building infrastructure, energy, transportation, environment, telecommunication, and project management. We also offer integrated service in geomatics, reality capture, and a lot of other integrated service. And we are mostly based in Canada. So we have more than 2,600 employees through the Canada. We have many offices in different region, in different provinces. And let's talk about a little bit more about the Reality Capture Excellence Center. We do offer the service through the Canada. We do have a drone survey and inspection group, a georadar group, 3D scanning and lidar, and traditional survey group, and then we have a scan to BIM group. So we do have many type of equipment in our group. I'm not gonna explain and show them to all of you today because that was not the goal. Obviously, this is a little nice project that we've did at the Olympic Stadium in Montreal. It was for a indoor and outdoor inspection of the structural of the facility of the sites. So it was an interesting project where we did assist the engineer with great HDR imagery for this project. We also have a group, as I was saying, of GeoRadar, and this project is quite interesting because we kind of combine all the expertise within one project. So we did a 3D scan of all the underground parking of the project of a parking in Ottawa, and then we did the GeoRadar of the slope, and then we did also a scan to BIM project. So it was a very interesting project for our group because we've combined all the expertise that we have. This is another project. It's Canada Lachine in Parc Canada. Actually, it's a 3D LiDAR survey that we did. So it's an example of the kind of survey that we did with a drone and a LiDAR technology that we have in our group. And this is a little small project for photogrammetry. So we do a lot of those kind of a heritage building project where we capture the details of the buildings, the facades of the building to create order photo to scales and create deformation analysis as well. So we combine 3D scan and photogrammetry process with a drone to do that. So that is a brief overview of the kind of project that we do in our group. But let's talk about the project that I want to present today. Was a great project that we've started 1 year ago. So it's a huge tunnel. It's a huge infrastructure that has 2.1 kilometers per direction, and we have different lanes joining each direction, and we have a lot of ventilation towers. And it's an old construction that has been built between 1970 and 1974. And we have a second tunnel that is around 650 meters per direction, and we have two towers for ventilation. And it has been constructed between the 80s and 85. Around these tunnels, we have towers, we have lanes, we have corridors that connects to those lanes. Those corridors are basically used for MEP services, so electrical and instrumentation, fire protection, and maintenance. So there's a lot of ventilation system in there and equipment around the tunnel. So it's not only the tunnel, but it's all the infrastructure around it. It's a pretty big project. There's also the air supply system, fresh air, gas extraction, smoke extraction, the fan, and various equipment around the project, which when everything is underground, it's quite complicated to understand where are all the equipment and how do we access it. And even people and manager that works on this project for many years had a hard time to demystify where they were and and find out the layouts and everything was sometimes hard. So having a 3D scan of all the infrastructure, helping the project have been a great idea that we've been working on it since 1 year now. There's also other equipment around the tunnel, so generators for emergency control room, pumping station, gravity drainage system. So it's a lot of there's a lot of equipment around those tunnels that we needed um, um, to take measurement and assess the information and capture it and make sure that the as-built has been produced for the project. So to help many teams for this project. So we have a schedule that has been planned for this project. It's on a 10-year base system. And basically now we're at the phase one. So for the first year, we had some specific area that we needed to scan in order to plan the project. But we did scan the whole infrastructure right away in order to plan the next step to do also. So how did we proceed to the survey? We actually worked, we were 4 teams of scanning. We had 3 different teams of 4 people on site on different schedules. So we had 3 to 4 furrow at a time on site. We were a consortium of 3 different companies. So CIMA was actually in charge of the management of the 3D scans and the registration, the hosting on Cintoo, the support to the professional, while Syntec was in charge of the SEC protocol and FNX was in charge of the polygon survey and the 3D scan of the highway, so the lane. So it was quite a challenge for us to scan because there's some confined space and very complicated area. The sites is very huge and there's a lot of connection everywhere. So the strategic planning to make sure that the alignment was fitting properly was quite a challenge. We did register through many system, and we used a polygon to connect to the lanes, and we tried to connect all the corridor and all the confined space around the lanes within the polygon in order to make sure that we avoid any misalignment or drifting. So we did use many type of equipment to capture the survey. So we had, as I was saying, many Faro scanner to do the confined space, tower, corridor, and all the technical area that was quite complicated to access. We did use a RTC 360 to do the lanes. And as I was saying, we did a polygon. So we used a total station robot and GPS. We did implement a permanent target, and we've used spheres with prism in it. We also used confined space equipment, a lot of confined space equipment, and a lot of lights in order to have a great visibility through the tunnels and the underground and confined space around the tunnels. So just fun facts here. Basically, it took in 3 different time slots in 2020 and 2021. It took an average of 800 hours spent on site over 20 weeks to survey. And the last registration calculation took around 14 days on the computer process. So I'd say at the end, we have for the initial survey, because you're going to see that we're surveying through the construction and while the process is moving along. So that's why we say it's a 10-year project, because we're going to scan all along during the construction and the evolution of the sites. But right now, the initial data, so the raw data before it was processed, is 600 gigabyte. I've looked into the RCP file. We're more around 1.5 terabyte of data when we convert it to RCP file. And we have around 4,000 scan station as to now. We're planning to move up to 6,000 very soon by the end of the year in 2022. Let's explain why we choose Cintoo and why it's so useful for a project. Basically, it facilitates the accessibility of the data. Viewing 4,000 scans and giving access to many stakeholder of 4,000 scans is quite complicated. We are able to create group access, so that's very interesting because you're going to see that we have different type of group that needs to access the data. So different type of we can manage the type of access to, and we can also monitor the access through a activities report. So that's very interesting because we want to monitor who's downloading what and who's having access to what and when. Here's an example of the group that we have created. Basically, we have group that can download. We have group that can manage the data and integrate the BIM model. We have group that is conception orientation, and we have a surveillance group, and we have a inspection group, and we have a client and contractor group. And we also have divided different type of access for different type of group, and it's very interesting to know that we use Cintoo to officially transfer our data to the group that required it, and we can track who and when the data has been acquired. So that was a very interesting facts for us because we wanted to track where the data was downloaded and at some point what was downloaded. So that's a great example of why we choose Cintoo. To be able also to manage and view on a timeline of 10-year projects. So basically, if you want to go back and view older survey, that will be very efficient and interesting for the purpose of the supervision of the project. So here's an example of a lane that has been done many times over the schedule for construction analysis and supervision analysis. And we even use it to do some comparisons. So I'll explain a little bit later what we did, but we did integrate a CAD model in it and compare to the actual sites in order to see the results. So why we've chosen Cintoo is also because we were able to create many work zones. So because the survey is so big, we needed to be able to split the area in order to make sure that, because that's very interesting to have 4,000 skin to have access through Cintoo, but it's more interesting to have, a work zone where we can find very easily if we need to work in a tower or in a lane or a corridor. It will be more efficient if we just load those data instead of loading the whole tunnel. So managing work zone would be was very interesting for us. So I'll show you a little bit how we work with the data and what we did with it. Because as I was saying, it's 4,000 scan, it's a pretty big sites. It's really hard to load even on Cintoo the 4,000 scan at a time. So what we did is actually we implement a CAD drawing of the infrastructure so that we can avoid loading all the scans to physically recognize where we are, and we could physically see, the lane, the line, the highway names, and the corridor names or the tower names, so that we can physically go where we need it more easily, and we can activate then the appropriate work zone that we filtered out that is interesting for us. The notes are very useful also for us. So we're able to create issues and address it to a collaborator on a project. So as I was saying, there's many different companies working on that project, many groups. So we can address issues to a different groups or a different type of person. We can use the tagging, so structural, mechanical, inspection, conception, to filter out what is useful. We're able to create a personal note as well, so to keep it more private for different people. They want takes notes to use it further on a report or inspection report, so they can use it as well. We did, as I was saying, we did use a comparison tool in Cintoo to integrate CAM model in the survey during the construction to validate templates, slope analysis, volume analysis, and new conception to be validated. It's very interesting for us to do that because we can demonstrate to the other team within the project, even if it's the contractor or the conception team or the supervision team, the issue that could goes on. So it's something that we've been using a lot over the past few months to make sure that templates are being followed and we can compare it through. And it's very interesting during meetings with clients and stakeholders showing the issue and where we need to focus the project. That's very interesting project where actually you can see the crop. So we use Cintoo, as I was saying, for presentation a lot in meetings with different department or different discipline. And sometimes we use the cropping tools within Cintoo and save it to prepare our meetings. And it's quite interesting to see that we were able to represent the street, the section of an old drawing through the 3D scan, so we can see all the lines, the highway and the lines that are superposed, and the stairways and the ventilation system in between. So that's quite interesting to be able to show that to the client and the stakeholder in the project. So I think that's pretty it. If there's any question, I can answer them. Maybe I can also show the project live if there's any question.
Yeah,
I can.
Yeah, Julie, we actually had a couple of questions here. So the first one is roughly what was the tunnel length that the project is on?
The tunnel what?
The length of the tunnel?
The length. It was, well, the tunnel itself was around 2.1 kilometers on one side, but we had to do both sides. So at the end, we had 4 kilometers. But if you calculate all the corridors and the air vent system that we scan at the end, if you put that one to another, I think it would, we could say that we've scanned around 10 kilometers long. That can be pretty much, but if you want to know the actual length of the tunnel, it would be 2 kilometers. Okay.
And then another question. So what was your typical scan resolution? Was it like 10 million points, or did you do a higher resolution than that?
So for those who knows the affair, we we used a quarter resolution with 3-time quality. So I'd say we've ensured that we've kept a 1 point every 5 millimeters in order to make sure that we have a highest, like the resolution that we needed. So at some point we kind of filter out during the process the resolution to keep 1 point every 5 millimeters. Okay, great. One more question is, they were asking, how did you get the CAD model into Cintoo? And I can help answer that if you want.
Yeah, thank you. Yeah, so if you use our visual, our VA tool, you can actually bring it in through BIM 360. So basically, you can take a 2D CAD model or 3D CAD model, bring it into Navisworks and save it as an NWC, and then you can use our model import through BIM 360 to bring that in and overlay it on top of the point cloud data. I think that's the majority of the questions here. Oh, there was one question, and then one other question, Julie, if you could help answer, is what did you use to do point cloud cleanup and registration? What product did you use to do that?
We do use the scene software, and we do have a add-on. We purchased a add-on product that help us filter out all the edges and all the points that are not useful. The name exactly, it's quite hard to say. I would say it's on the fair market software that you can purchase this add-on cleanup system. So I would say go on Faro Market. You can purchase some add-on to clean the data.
Great. Well, Julie, we appreciate you sharing your use case with us. Once again, great project, great use of Cintoo, and like I said, we really appreciate you jumping on to help us and explain to our customers, a use case of how we use Cintoo and laser scanning to help solve the issues you saw or come across out in the field. So now I would like to turn it over to Dominique Poulican, who will discuss some of the Cintoo new features that have come out in the last couple months. Dominique, you want to take it away?
Yes, certainly. Hi, hello, everybody. Can you hear me?
Yes, we can.
Okay, good. Thank you. First, thank you very much, Julie. That was a great presentation. I love it, the way you presented it on how Cintoo is being used on a daily basis with very large projects to solve real problems. What I'm going to show you is new features that we lately introduced into the product. The first one is called TurboMesh. You already saw the video displayed by Rob, but let me explain what we do in a real case scenario. So let me go into one project like this one. I think I have already loaded it here. So here we have a typical project inside Cintoo with various layers of information, being a site maps, CAD models, 2D drawings, scan data. What you know already from Cintoo is that we turn high resolution, point cloud data into very high resolution 3D meshes. And then you can navigate your scans and display that as, 3D surfaces. Okay, here you see the mesh for this particular scan. Of course, the mesh comes with a color as well, but also intensity, etc. So where I think Cintoo is well known for this mesh quality we have in each scan position. You see the mesh streaming is very fast. On every time I can zoom in on stream even more levels of details. We have more than 15 levels of details until I get the full resolution of the scanner. Okay, so this is the existing solution as you know it. What we have been introducing lately is this TurboMesh. So what you had before TurboMesh is that when you move outside the scan position, so we go into the full 3D navigation, here we would display a low-res version of the various meshes of the scene in various, low level of detail. So what we do now with this TurboMesh is that we have the highest possible mesh resolution in any case. Okay, so let me do this again. Let me go back to scan mode where we have the full resolution, let's say for this particular scan. So this is a high resolution mesh for this particular scan. Now with TurboMesh activated, when I move to 3D navigation, you will not notice any difference. And if I get out from my scan position, you will see that in all cases, I will be looking at a very high resolution mesh. And of course, works the same with the color, of course. Okay, so here we do not compromise on the resolution of what is being displayed, being either in full, in scan position or outside the scan position. And this is like a revolution. Nobody has been able to do that so far. Okay, so whatever the navigation you have, either scan to scan or full 3D, you always make sure that you have the full resolution of your scan data. Okay, let me show you this one on another example like this one. Okay, this is another small data set that has also some CAD model into it. So let me switch to our surface mode here. Let me remove the CAD model just to show you TurboMesh. So here what you see in this scan position is a very high resolution mesh. When I go to 3D navigation with TurboMesh activated, you will see exactly the same mesh resolution. So you can now navigate your scans in full 3D mode with the highest possible mesh resolution. So what we claim here is that our world is not made of point cloud, okay? Or, okay, you capture with point cloud, but this is not why you should see the world in 3D as a point cloud. You should see it as it is really, which is made of surfaces. Okay, so this is what TurboMesh will do for you. And this is available in full production now. You can navigate your scan in full mesh resolution. At the resolution of the scanner, no compromise on accuracy. You just have to activate this TurboMesh button when you go to 3D navigation. Okay, so that was feature number one. Feel free to use it. It's in full production now. What we also introduced lately is a capability to upload mobile scan data. As you know, Cintoo Cloud started with static scans. And again, it's about creating a high resolution mesh at the resolution of the scanner for each scan position. Now we can also do the same with unstructured data coming from mobile scans. So the way it works is I feel is pretty clever. So what we do, we will take the unstructured data coming from your mobile devices, being from Navis, GeoSLAM, Emesent, Leica, BLK2Go, Viametris, Gexel, etc. We'll take this unstructured point cloud plus the camera pass and eventually the panoramic images that were shot during the capture of the site. And then what we will do, we will restructure the unstructured point cloud so that your data look like it's coming from a static scanner. Let me explain you how we do that. So what we get first is your unstructured point cloud and camera pass. Panoramic images are optional because not all those devices will capture images. Then we create, we sample along the camera pass, and then the user decides, okay, I want to have a 3D scan every 2 meters, 5 meters, 10 meters is your call. And then for each one of the sample or each one of the 3D scans created, we compute which points are being visible from these exact vantage points. And then we create like a bubble view on which we apply the same multi-resolution compression technology and meshing technology that we have for static scanners. The reason why you do that is very simple. We want to keep the resolution, of course, of your scanner, of the scan data, no compromise on accuracy. We will generate panoramic images, although they may not be panoramic images in your capture. But the goal ultimately is to make your navigation much easier for non-experts, much easier to navigate scan to scan, and much easier to interpret thanks to the mesh viewing as well. Okay, so really you can turn your unstructured data as structured data as would be coming from static scanner, and you can also export now your data as structured data as well. Sorry. So let me show you a few examples. So this process will work for the Emesent Hovermap, a generic E57. If you're bringing E57 with a CSV file that contains a camera pass, that's fine as well. We'll work with GeoSLAM, BLK2Go, Navis VLX, M6, and also the Viametris backpack. So the way it works on this is when you run Cintoo Connect to bring in laser scan data, you will select this tab called Indoor Mobile Scanner. This is a choice you have. And then you have various files to fill. You have like the point cloud, of course, can be E57, PLY, BLK2Go as a specific E57 format for that. We'll also, you will bring the camera pass. So we are compatible with GeoSLAM TXT, Navis CSV, Viametris XYZ, etc. And also in some, for Navis, there is also a geolocation file, an XML file that will allow you to import multiple scanning paths into a single project. So let me show you some example. This is an example from the Navis device. Okay, and if I click on this one, you will be showing this data set. It's coming, so it's loading now. There are a few scans in this project. That's thanks to our good friends at TruePoint Laser Scanning. So this is a one floor only sorry, this is convention center. And so this is the data inside Cintoo. Of course, if you look at this as an X-ray vision, you will see all the scan positions. Okay, so what we did here for each scan position, let me take this one as an example. Here, of course, we have the source panoramic image coming from the Navis device. Okay, so you can navigate scan to scan as a set of panoramic images, but also we turn that into a 3D mesh. So when we go into a 3D surface mode, you see the high resolution mesh, we compute it for each scan position. Very similar to what you get from a static scanner, okay? So this is an example with, the Navis VLX data. Let me show you another example. This is coming from this Viametris company, creating this BMS3D device, a competitor to Navis VLX. This is also giving very good quality data. If I go into the 3D view now, you will be, this is a small project. This is a courtesy of this company in France called Viametris. And they do a really good job creating very high quality panoramic images. Let me go into scan mode. I can go into, this is a panoramic image. You see no distortion at all. Very good quality panoramic image. Very good navigation experience. And if I look at the 3D data created from this device, it's really amazing as well. So you have very high quality 3D mesh. The quality of the mesh really reveals the quality of the capture you get from the laser scanner of this device, okay? So you see the quality of the mesh, the range you have as well for this device is really amazing. So this is an option if you consider buying one mobile device. Let me continue this demo with the next one will be the Emesent Hovermap. I don't know if you are familiar with this device. This is a device produced by this company. The Hovermap is produced by Emesent based in Australia. And this is an interesting device, although it doesn't have any, as far as I know, it doesn't have any panoramic image embedded. You can capture data either by mounting it on a drone or by putting it on a backpack as well. So let me show you what it does. So here I go to the outside. So the outside was captured by having this device on the drone. You'll see very good quality data. Of course, in this case, for example, we didn't get any panoramic image, okay? So what we do when we go in scan mode, we can navigate scan to scan here, as you can see, okay? These are bubble views that were created by our restructuring process, okay? So we makes it much easier to navigate. And if I look at, again, the quality of the mesh that was generated from this device is very high. The quality is really good. Okay, and this is for the outside, but now if I go into the inside as well, let me go into the inside with a device mounted on a backpack. You see, very high quality device. Again, all those bubble views did not exist. We did produce them from the process. And if you look at the mesh here, it's really high quality. If I get out from the mesh here with my TurboMesh activated, you have a very nice quality mesh representation of your virtual space. So really good quality data. And just to finish, before we go for Q&A, let me show you what we get from the BLK2Go data, BLK2Go device, which is another handheld device, very well known as well by Leica. And this is handheld device. So let me show you this one now. Good news with this device, it comes with some panoramic images, as you know, but they are not full 360. When you go into the 3D view now, you will see all those, on here we sample about one image every 10 meters, something like that. So this is the partial panoramic image you get from the device. So it's not complete, of course, because there are no sensor where the person is holding the device. But in terms of geometry, of course, it's bringing the full geometry, okay? And you see the quality of the geometry is pretty good as well. Everything you see, those black holes here, is that because we are missing 3D data. So this data was not captured by the device. But anyway, in terms of navigating your space, being able to compare to a CAD model or be able to extract meaningful information, like let's put this in perspective view with X-ray vision here, you have very good quality data you can work with. And this is coming from the BLK2Go. So that's about it. This is what I wanted to show you today. these are all working in production. So if you subscribe or if you have already Cintoo Cloud, you can enjoy TurboMesh now. You can also upload the latest version of Cintoo Connect, which is called Cintoo Connect 2.1, and you will be able to upload your mobile scan. And of course, merge your mobile scans with static scans. And what we're working on now for Q3 will be to be able to upload the drone data as well by restructuring the unstructured point cloud all the same. So expect some really good, interesting capability in the months to come from us on these aspects. So this is all I have. Rob, do we have any questions on this?
Yes, we do. So I'm glad you mentioned drone data. So I've had several questions around when will we support the drone data? Sounds like Q3 to Q4 timeframe.
Yes, if you have, although we already have the process in place, but in alpha, in our own development environment. So if you want to see what it looked like, feel free to contact us, give us your drone data, and we will process it for you. You will see what we do. It's really giving really good experience.
Kind of a follow-up to that, Dominique, was when will we support mobile Lidar data, but more car-driven? So capturing like city streets and things like that.
Yeah, this is a longer term. There are so many, other, software platforms that do a good job with this point cloud data, even web platforms. The goal is different. The kind of, deliverables you expect from this kind of data is different. You expect profiles, you expect different stuff. So we will see if our high resolution 3D meshes help in these, kind of, use cases. But this is something we need to work on. That's more like 2023 though.
Okay. Another question was around pricing. So if you go to our website at www.cintoo.com/buy, you will see our different pricing packages. We start out at 500 scan package and then go to 1,000, and we can scale up to any number. Just to mention there that we're not a named user model. So we are not a named user model, meaning that with a 500 scan package, you can create as many projects as you want until you hit that 500 scan capacity, and you can also invite unlimited users. So please check that out. If you got any other questions, you can always send an email to sales@cintoo.com, and we'll be more than happy to help you. One other question here for you, Dominique. Let me find it here. The question is can they use RCS, RCP unified files without the camera path?
That's a good question. Our goal in Q4, after we process, this drone data in Q3, our goal in Q4 will be to process this unified point cloud that many companies have as legacy point clouds, for which they lost the structure. So yeah, there will be a way to be able to get rid of this. If you don't have the camera pass, what we will do, we will propose a way to define vantage points along a grid. Let's say I want a vantage point every 10 by 10 meters, basically, and then we will process your unified point cloud and create these static scans every 10 by 10 meters. So yeah, there will be a way to turn your old unified point clouds into a structured data. Even if you don't have the camera pass. Absolutely.
All right. And then I got a couple more here. Does Cintoo have any plans to have like an advanced cleanup tool, kind of similar to what Recap has?
Yeah, that's a very good recurring question we have. Yes, so there are plans. We are so overloaded now with new features, working on like a BIM model import for metadata and disciplines, working on asset management tools. This is coming high on the list. So be confident that there will be more on this, but not before the end of the year though.
And I guess one more question here. I believe I answered it, but they asked, can they put a mesh file into Revit? I'm not sure I completely understand this question, but it sounds like they want to know if they can bring a mesh from Cintoo into Revit for modeling.
So yeah, what we do propose, this is still a beta feature, but we have this unification process in the cloud. So you can select a crop area and generate a single mesh out of it. taking into account the best contribution from each scan, from each mesh, from each scan. So this is called the unification process. You can select the mesh density, the mesh format. So for Revit, you would need to select FBX. The way to go to Revit, though, will be to go through Navisworks, and we have documentation on that, online documentation on this one. So you upload your FBX into Navisworks, and then you get out from this to go to Revit. What I know, though, is that you lose the texture mapping when you go to Revit. For unknown reason, they don't support texture mapping.
And I got one last one here. Is can Cintoo register raw data?
No, we don't do the registration. The registration is supposed to be done by the software device, software coming with a device like Pharocene, Cyclone, or now Navis Ivion, etc. So we get registered data. Okay, registration is a survey world. There are so many good solutions to do that now.
Great. Well, I think that's all we have time for the questions today. Thank you, Dominique. Once again, I'd like to thank Julie Petit from CIMA Plus for presenting today. Great customer story. If you have any other questions, please reach out to us or email us at sales@cintoo.com. And please feel free to visit us on our website at www.cintoo.com. Once again, thanks everyone for your time today, and hope you have a good rest of the week. Thank you.
Thank you.